Hi, and welcome to 2.5 Measures of the Center of the Data. Okay, there's going to be two statistics that we use to measure the center of the data. The first one is the mean. This is also known as the arithmetic average. Most people just think of it as the average. It's when you add up all the values and divide by the total number. So if you wanted to calculate the mean weight of 50 people, you add up their weights and divide by 50. This is the most common measure of center. And the median we've already talked about, but let's re-hit that again. This is going to be the middle number on the ordered list. If you wanted to find the median weight of 50 people, you'd put the data in order and find the number in the middle. Generally, the median is a better measure of the center since outliers don't affect it as much as they affect the mean. Before we get really jumping in with this, we're going to practice a little bit with sigma notation. So this is a way of writing sequences. If we have a sequence A1, A2, A3, the index or the little subscript is the way we note the term in the sequence. So 1 means the first term, 2 and the a sub 2 means it's the second term, and so forth. We can write out the sum of the first n terms using summation notation or sigma notation. This notation derives its name from the Greek letter sigma, which is that capital symbol right there, and we use it as follows. So this is my sigma notation. This says we're going to sum the sequence AK from k equals 1 to the value n. So it's equal to A1 plus A2 plus A3, etc. Let's talk a little bit more about the different parts of the notation. So the letter K down here is called the index of summation or the summation variable, and that's the value that changes. It's starting with 1, and it's going to go all the way to the value of n. The idea is that you replace each of these values in your K over here. So first it's valued at 1, then it goes to 2, all the way up to n. The fact that it's a sigma tells us to add these all together. Let's look at a couple examples. If we wanted to sum from 1 to 10 of just K, that would mean first we'd put in 1 for K, then we'd put 2 in for K, 3, etc., all the way up to 10. We'd add those guys all together. I don't know what that is off the top of my head. You can count, you can add it up. What if we wanted to do the sum from K equals 1 to 100 of K squared? Every time we see a K, we're going to put in 1 the first time, so 1 squared, 2 the next time, 2 squared, 3 squared, all the way up, 99 squared, plus 100 squared is our last one. To figure out the sum, we would just simply add up all these values. I would like you to write out the right-hand side of this sigma notation problem. It's the sum from K equals 1 to 6 of K plus 1 squared. Pause the video right now and write out the right-hand side of this. All right, were you able to do that? Hopefully you got 1 plus 1 squared. That's my K. The next one would be 2 plus 1 squared, all the way up to 6 plus 1 squared. All right, sometimes we don't want to put a top value. We don't know exactly where it's going to end. We want that to still remain unknown. So we can say K equals 1 to M, and we just assume M is M is integer. So if we want to do that from K squared, instead of going to 10 or whatever, we just put 1 squared plus 2 squared all the way up until whatever M is squared. So we can leave that more vague. Why don't you write that same more vague top value for K plus 1 squared? Pause the video and write it down. All right, it looked a lot the same as before. 1 plus 1 squared, 2 plus 1 squared, all the way up till our last one is going to be M plus 1 squared. All right, let's get a little more practice digging in with sigma notation. I would like you to pause the video and find each of these sums. All right, you make it back? Let's go ahead and go over these one at a time. Here's my first answer. I'm going from 1 to 5 of K squared. So 1 squared, 2 squared, 3 squared, 4 squared, plus 5 squared. That's 1 plus 4 plus 9 plus 16 plus 25. Turns out that's 55. Let's look at the next one. This one starts at a different value, and it has a different index. It doesn't have K this time. That's okay. You can actually use any index you want. So this one goes from J equals 3 to 5. Our first value is 3, and our last value is 5. So that's 1/3 plus 1/4 plus 1/5. Get some common denominators, add some things up, maybe use the scientific calculator. You come out with 47/60. All right, let's look at number C. Again, different index. This time we used an I. Starts at 5 and goes to 10. So it's 5 plus 6 plus 7 plus 8 plus 9 plus 10. Add those guys up and you get 45. And finally, D was a little bit of a challenge one. You have I equals 1 to 6, excuse me, but you don't have any I over here. What does that mean? Well, it means you don't have anything to plug I in. So the first time you plug in I, you just have 2. You plug an I in again, that's 2. So that's 1 I, 2 I, 3, 4, 5. Oops, I didn't mean to do that. 5, 6. So that equals 2 plus 2 plus 2 plus 2 6 times, which is 12. But since there is no index variable in here, each time the output value is just 2. All right, so that was a little bit about summation notation. Let's talk about using a formula to find the mean. We have this new summation notation. We're going to use it to write a variable for the mean. When we use x bar, we're talking about the sample mean, not the population mean, and we call that x bar. Here's my summation notation. Sometimes people write it on the right like this, so I wanted to include that too. It's the same as if it said I equals 1 to n, xi over n. Well, what does this mean? Well, it's the same way as calculating the mean as before. We're going to add up all the data values, x1, x2, x3, all the way to xn, and we're going to divide by the total number. So it's still the same way you've always calculated the mean. When we want to calculate the population mean, not the sample mean, we use the Greek letter mu. And we say the population size is a capital N. Same formula. It's just when we use mu, we're referring to populations, and we use x bar, we're referring to samples. And one of the requirements for the sample mean to be a good estimate of the population mean is if you take a sample that is truly random. All right, so let's do an example using our new formula, which is really still the same way we always calculated mean. So here's our sample, 1, 1, 1, 2, 2, 3, 4, 4, 4, 4, 4. And we want to find x bar or the sample mean. So I would like you to pause the video and try to compute the sample mean. All right, are you back? Were you able to just add up all the numbers and divide by the total number, which is 11? You should have come up with 2.7. So it's a new formula, but it's still the same idea. And now let's go ahead and do an example when the mean can be calculated by multiplying each distinct value. So in this example, we have a frequency table. 1 happens 3 times, 2 happens twice, 3 happens 1 time, and 4 happens 5 times. So instead of writing out the data like they did in the previous example, they gave it to you in a frequency table. Well, really, it's still, we have 1 3 times, so it's 1 1 1. We have 2 2 times, 2 2. So you could just go back and translate the frequency table to a list. But you don't actually have to do that because when you add 1 plus 1 plus 1, that's the same as taking 3 times 1. So we can do 3 times 1, which is what this symbol is telling us here to do. The data value 1 times its frequency 3. So 1 times 3. The data value 2 times its frequency 2, et cetera, et cetera. And the denominator tells you add up all the frequencies. Well, that's going to give us a total number of values because this one happened 3 times, so there's 3 data values. This one happened twice, so that's 2. This one happened once, 1 data value, and 5 of these. So let's look at what the formula for that looks like filled in. So when we fill it in using a data frequency table, we have 3 times the number 1, 2 times the number 2, 1 time we have the number 3, and 5 times we have the number 4. Do the multiplication first, then the addition, because that's PEMDAS. Divide it all by 11, and we come up with 2.7 again. All right, so let's do an example using another data where we find the mean and the median. Here's another example for you to try. I would like you to pause the video right now and calculate both the mean and the median. If you want to put it in a frequency table, you can. All right, is this what you got for the mean? 23.6, hopefully. And for the median, it's going to be located for the 20th and 21st values. Both of those values, where is that right here? Both of those is halfway through the list. I have a list of 40 is going to be between the 20th and 21st. Average the 20th and 21st values, well, they're both 24. The average better be 24. So that's our median value. All right, so we don't need to do too many things by hand. It's also good to be able to do things in Excel. So what we're going to do is we're going to do calculate mean and median by Excel to do a little more practice. So what you need to do is you need to go to the My Open Math page and download the Excel notebook that goes along with this lecture. If you want to just type these values in, that's fine, but it's kind of boring to do that. So let's go ahead and download the Excel file. Escape out of this. Go to My Open Math. Here's the Excel file. I'm going to download it. Open it. Enable editing. And here is my data all nicely typed in for you guys. And the first thing we're going to calculate is the mean. And the second thing we're going to calculate is the median. Now, Excel uses the word average for arithmetic mean. So we type equals to let Excel know we're doing a formula. Average, average. Left parenthesis. Select all of our data. Right parenthesis. And there's the average, 13.94. If you want less decimals or more decimals, you can select the answer. And then on the home menu, you see this button right here. This tells you all about the format of the number. One thing you can do is you can make it have less decimals or more decimals. I always do it the wrong way. I'm not sure why. I want it to have less. Maybe we want 1 decimal place, and it will round it for you. The decimals aren't gone. They're just not shown. And hopefully you all remember how to do the median equals median. Select all my data. Right. And the median is 13. All right, awesome. All right, let's talk a little bit about interpreting the mean and the median. Let's suppose there's a small town, and in the town are 50 people. One person in the town earns $5 million a year, and the other 49 each earn $30,000 a year. Which do you think is a better measure of the center, or the mean or the median? Which would you use to describe this town? Calculate them both and explain your solution. All right, so I'd like you to pause the video, calculate both the mean and the median, and explain which one you think is a better measure of center. All right, are you back? Well, X bar is going to be, 5 million for one person, and 49 people have 30,000 out of a total of 50 people. So that turns out to be $129,400. So that's the mean. The median is going to be 30,000 because if you think of the list, it's going to be 30,000, 30,000, 30,000, da 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 da. Last value 5 million. So the middle value in that list is bound to be 30,000. So I think the median is a better measure of center here because there is one big outlier and every other person is just earning $30,000. All right, so the last new statistic we're going to learn today is going to be called the mode. And this is another measure of center, and this is best used in very large data sets. The mode is the most frequent value. It is okay to have more than one mode as long as both modes have the same frequency and that frequency is the highest. That's called bimodal. So here's an example of 20 scores from a statistics test. And the mode on this one is going to be 72 because you can see it happens 1, 2, 3, 4, 5 times. So it occurs 5 times. You just write mode equals 72. All right, the last thing we're going to talk about in this section is calculating the mean of a grouped frequency table. Let's suppose we were given a frequency table about a statistics test. It says there were the grades between 50 and 56.5, there was one student. From 56.5 to 62.5, there was 0. From et cetera, et cetera. From this information, we want to try to calculate the mean. The trouble is we don't know exactly what value the student had that was between 50 and 56.5. We don't know what the exact values the 4 students had who are from 68.5 to 74.5. So what we're going to do is we're going to take the midpoint of this interval found by averaging those two numbers and assign that to each student. I've done this in the next table. So if the midpoint of it was 53.25, so that's going to be assigned to one student. 59.5 is assigned to 0 students, 65.5 is assigned to 4 students, etc. And then we find the midpoint using our midpoint formula using a frequency table. We assign 53.25 to one student, 59.5 to 0, 65.5 to 4, etc. Adding those all up, we get 1460.25. The total number of students, if we added this column, is 19. So the average value is, I didn't even actually bother computing it. Let's have Siri help us. What is 1460.25 divided by 19?
It's about 76.8552.
76.86 was the average value for this test. Now, that's not going to be exactly right. If we had all the test scores, we could find the exact right mean. This is just the approximation based on the information that we were given. All right, well, this is the end of section 2.5, and you should be ready to go on and do the homework.